I'm on now? Okay, only for the recording, yes. Okay, ladies and gentlemen, dear colleagues, welcome to this Ph.D. defense, where we have Peggy Mischke that will defend her Ph.D. thesis entitled China's Energy Revolution, Measuring the Status Quo, Modeling Regional Dynamics, and Assessing Global Impacts. So, and my name is Publ Mortorst. I'm head of the Systems Analysis Division here at DTU, and I will be your chairman today. And a special welcome to our examinators, where we have Erik Algren, professor from Chalmers, where we have Cora Sandholt, which is chief supervisor. Was it that? Yes, chief expert, you're called actually, at CENRIC. And then we have our own Birte Holst Jørgensen from DTU Management, which actually has been chairing the evaluation committee. And of course, a special welcome to you, Peggy. Without you, we wouldn't be here. So it's really good to see you. And to your supervisor, Kenneth Carlson. You actually have a co-supervisor as well, Professor Ji Wang.
Wang Yi.
Wang Ji, okay.
Wang Yi.
Wang Yi. Okay, from the Chinese Academy of Science, but he couldn't be here today. So, yes, and the program for today is that now Peggy will make a presentation for the next 3/4 of an hour. And please stick to it. If you go significantly beyond, then you know I will interrupt you. So,
Okay.
and following that, we will have a short break, and then the evaluation committee will have the chance to give their comments and questions to Peggy. And actually, there will be a chance for the rest of you to come with questions as well. And then, if you have any questions for Peggy, I ask you to give me a note in the break with your name, and then I'll put you on the Q&A list. So, that's actually the part of it. Following that, the committee will final the evaluation, and we will have a small reception at the end. So it means that I'll hand over the floor and the word for you, Peggy.
Yeah, super.
Good luck.
Thank you. Thanks, Paul Erik. Yeah, welcome to my PhD defense. It concludes a 3-year research project on energy in China, and thanks all for being here today at Riese in Roskilde, and also to let you know this is first of the PhDs here in the department that will be video streamed. So there is some YouTube video later that's being produced, and we are on mic. Okay, topic is very, very broad because I was very interested in learning something more on China's energy sector, what's going on in China, and yeah, that's what I made out of it. I give you here a complete overview in the 45 minutes I have on the topic. So I first say something a bit about the framework, how I structured the research, objectives, my motivation, research questions, research areas I went in. I had many collaborations with Chinese colleagues, so I explained this a little bit more. And then second part is the main part here. And my thesis is paper-based. So I give a quick summary, a very little highlight of 7 core publications I did in different collaborations. It should be just to tell you a bit like what is it about, and if you're interested, feel free to discuss with me later, or then you know also if you're interested in one special one, in which page of the 200-page PhD thesis you have to go to learn more and go into the details. And then conclusions, of course. So first part, framework, and yeah, some pictures also. As I traveled 4 times in the PhD to China, I bring some little Chinese pictures and flavors with me as well. Okay. Before I forget, and that's also something which I enjoyed a lot in the PhD, I had so many collaborations in the end. I started here more or less by myself, but then many, many doors open, many people, institutions get interested in it, not only research, also consulting companies, institutes also. I discussed some topics at the IEA in Paris with some China energy colleagues, or many Chinese universities also invited me to discuss a little bit. And yeah, I have to thank all of them also for financial support for inviting me, and just to acknowledge it was a nice big collaboration that came out of it in the end. So motivation. For people who are here and don't have so much background on China, just to give you a bit like the amazing story of China's development since the 80s, which you see here in the upper part, and for the energy sector to now, which was like most recent statistics about 2012. And comparing it here, you have a bit global overview just to see like the global energy mix, 1980, how big it was, 400 exajoule. And then it increased to like 700, almost 80 exajoules almost today. And China, they just had 26 exajoule in 1980, and now they're at 128. So they were increasing their whole energy sector, supply, consumption, demand, one can say by a factor of 5, while the total world was like at a factor, an average at a factor of 2. And this, of course, is enormous for a country. And people who know China also know that by no means the story is finished. The ambitions are finished, and it's going on. What's characteristic also one sees here is like in gray the coal production, not excluding imports, they're elsewhere, but just coal production, which is a key characteristic of China's energy sector, that it's very much dependent, was always on coal. And some research also I did to see a bit like what's going on, where are renewables, and big debate. The title of my PhD, actually, Energy Revolution, comes from a recent citation from President Xi Jinping, who also said strategically, just like 1 year ago at a very high-level meeting, that there need to be more efforts to revolutionize China's energy production consumption habits in light of changing dynamics in the global energy markets. China faces challenges to cope with rising energy demand, supply restraints, huge environment costs, and backward technology, which also shows that more and more researchers and energy sector experts in China also look more and more global. Investments are going out more and more global. And no matter in which country in the world you are today, I think more or less you've been in touch with China. Maybe you don't know yet so much upfront, but there's so much collaboration, and in very recent decades only it's increased so much. So it's very interesting. Then what is still a big research topic is then, okay, there's some energy revolution going on, but how can you try to measure this? How can you try to figure out also a bit more what's going on inside China? Are there any regional differences, characteristics? And there's a lot of work also being done on modeling any future development energy scenarios for China, especially this year going towards the next COP in Paris in December. You will find almost every big country with energy modeling groups, they will present some energy scenarios for China, and there's also work being done in China. So I tried myself to find some ways, a new research areas or some research gaps where I could contribute a little. And then what I found out also, what's really important to me is also to benchmark and visualize more all kind of results, scenarios, models, tools. I divided it into, in the end, into different research areas with different research questions, because the topic is really broad. A lot of groups are researching on it, and I found it also interesting to combine things and collaborate on these things. In the beginning, I had to really do some tough work on energy statistics, as China's energy statistics are getting more available, but there are still some issues, how consistent they are, how internationally comparable they are. And if you try to model China a bit better, which was my aim here, not just having national indicators for China, but breaking them down more into sub-regions, you have to do some tough work on also provincial energy statistics. What was the starting point in view of going a bit into energy system analysis and look a bit current state, what are current disparities, and then also looking a bit what models are used, what are plausible scenarios and pathways for China among the many. And then I found also some collaboration, and from my background also working a lot as an engineer on renewable energy technologies, I was always keeping some eyes and ears open if somebody wanted to collaborate a bit on on this side of the story, and I was happy to work a bit on this as well. These broad areas, of course, needed different methodologies and tools. So I combine also in my different papers then different things, how to address research questions. So I try always to do literature reviews, benchmarking, comparison of results, of models, of scenarios, as much as data are available. I propose some new, sometimes pragmatic methodologies to harmonize Chinese and international statistics. That was also much discussed during my PhD, this work. And then also I did some collaboration with Chinese colleagues in the Energy Research Institute and from the Japanese National Institute of Environmental Studies to sit together and work together on some scenarios, models, pathways for China that we think as a mixed collaborative group are plausible. And this I like actually very much because it shows a bit the progress I did over the 3 years and the publications also then that I will explain later. And I started here very much by myself, sitting at DTU and getting myself into statistics and reviewing then some modeling tools. And then I had the first collaborations where I could go a bit deeper into statistics and energy flow analysis of China with a friend and colleague from Tsinghua University. This is this publication, and this one is some huge model collaboration later that, took more than 1 year, I say even. And then sporadic also, I had some solar power generation and wind energy insights in between when there were collaborations done with other partners that just appeared. And now I want to spend most of the time actually to give you some highlights of the publications, and we can hopefully discuss some of it later. Here you see, just as an overview, the different publications can then be mapped to the different research areas, and sometimes also one publication addresses different issues. Very often if you work on modeling, you also have to do something on energy statistics. While these more power generation technology specific ones can be seen as standalone, but in the end also, if you want to model China's energy system, power sector, of course they also can give some information you can feed into models. And this is written out just as an overview and to see also what kind of publications there are. It's like from A to G. The first one is a working paper that I published in the beginning, 2013. Then some papers in energy, applied energy. And actually just this big model paper was accepted finally today. So I'm very happy actually that this is now going into press. Then some, on the wind energy, it was some DTU technical report. And for the models also we had in the IEA ETSAP, the Energy System Technology Analysis Program, where our group here from DTU represents Denmark, and then there are many other national groups working. We also worked together in model coupling in the last year, and then actually writing quite a big book on it, and then going global and in different country studies. And then, last one, this is still under review, but it's been now in the first review, and I hope also this is soon going to be published. And now a bit into the details, and very quickly indeed. As statistics, the problem is a bit with data that, quality, reliability of energy statistics, economic statistics. You find a lot of research, critical research on China. It's getting better, it's been a bit more published, but what was hindering me a lot is that the statistical system is very different from the system we use. So there's by no means something that can be easily standardized to IEA's energy balances or other countries. China still works in tons of coal equivalents, for example. and also the level of aggregation of data. There's not much detail available usually in energy statistics compared to countries like Denmark, Germany, US. So I had to be in the beginning very pragmatic to basically what I did. I wanted to do regional energy balances of China, and so I worked with regional and provincial statistics of China. And then there is a national energy balance of China from Chinese energy authorities, and then there's one from IEA. And they don't really match, and they are really different. And as I wanted to work on global scenarios, I needed some global benchmark. So I decided to use IEA's energy balance as a benchmark, and then I matched regional shares for every indicator by indicator to this IEA benchmark and constructed by myself with Chinese statistics an international energy balance that can be linked and traced back into Chinese statistics. It is very pragmatic. I asked all experts I could find about it, and I put it online also. It was downloaded and read. And so far nobody has told me a better method to just go ahead and be able to also look a bit more deeper into regional characteristics of China to do this. To give you an overview, what is then in the paper very much in detail, this is how I break up China into like an east part, the highly developed eastern provinces. Then there's a central part, which has a lot of coal production, current coal production, past coal production. And then there's a big part that is classified often in Chinese energy debates as West, which is more or less underdeveloped, poor, but in the focus of development right now. And my working paper then has like 50 pages or so where I have like IEA energy balance and indicator for China national here, then what you find in Chinese statistics, and then how I can calculate regional shares for this indicator from provincial level of details, and the approximations I need to do because data are not available in this level of disaggregation, or it's also data cannot be classified per international standard in this category. So I do my own rearrangements to come up with some international compatible regional energy balance for China. This is, a bit boring statistical work, but I use this later to model China, so I would not be able to do modeling with regional level of details. Haven't I done this? Next publication, something different. I was interested in the beginning also to look pretty much like what's the Chinese perspective actually on their modeling tools and scenarios, really looking only on Chinese institutions and not what's being published in the US and Germany, elsewhere. And what modelers are there, where are the groups, what kind of tools they use, with whom they collaborate, how open they are in putting the models out, the data, the scenarios. And actually I was expecting to find this somewhere in the literature, but I couldn't, at least not in the English language literature. So I did another paper in the beginning to just put up some model and scenario database for China from Chinese institutions only. And then I tried to find indicators to do some model scenario benchmark comparison. Results they publish with different tools and different groups. Do they have some common results they always report according to their national policies as well? I could find some. And what's important to mention also, I didn't limit myself to scientific literature because then I would miss out lots of government reports and lots of influential groups like the State Council's Development Research Center, which do not put out their results and their models in the scientific literature right now. And I looked like since 2005, since like the COP in Copenhagen, and found 18 tools, and then I could do some benchmarking. The indicators I found commonly, which all model scenarios usually report, was gross domestic product, energy demand, and also emissions was a lot focused. And I could rank and classify them a bit and see from benchmarking it to 2010 what do these research groups expect? Like, how much more energy does China need? How much more GDP growth will there be? And what's then with emissions? Some challenges, of course, with the data and the models, of course. But it helped me a lot to understand different perspectives and also different institutions I want to contact in China later to do it. And they are rather careful, I would say, or were in the past, on like long-term development. This is just a highlight. It's too small to read, but it shows you a bit when you're interested in this, go into paper, you will find like the different models with their names, the institutions. And I did some kind of database also. What's the modeling approach? Where you get access to the data? Where is it published? How often is it used? It links back to the publications they have made. So it's really useful if you're interested in this topic. And this is just in some snapshot of the ranking I did. Here it is for CO2 emissions. And you see also that quite a spread, even if you ask Chinese modelers in the past, where they expect to have, or the increase just to the year 2010. No matter what tool you use, it's quite a range, which we know from international models as well. Good. Next paper. Something that goes back into the statistics area, which then was my first collaboration also with China, and I wanted to do some. Now I had like pretty much in mind my regional division of China I want to work on, which was also feasible to do. And I wanted to map and visualize some energy flows, what's going on inside China. And I found a colleague interested, working also with Chinese literature sources and Chinese data sources then on some statistical methodology and filling some missing links which are not provided by the Chinese Statistical Office or Chinese energy authorities. And it's our assumption then how we group and classify major fuel flows in China for the most recent year we found. And then we could say also like between different parts of China, what are their major fuel flows? What's the main characteristic? If you go into China, what's going on? And you see that like West and Central China pretty much supply the coal for east of China, and pretty much the consumption of all kind of big fuels is taking place in the east. So huge disparities in China, as like going back to the 80s, still there. And what's doing this combined analysis from national to through provincial to regional, we always see also, of course, data challenges, differences, and we can. Doing this in a comprehensive way together, we can also map out like where are the problems with the data in this year. And the presentation or the publication then has some pictures, of course. So this is for East China, some fuel flow diagram, and then we have a national one, and for West and Central, that's again the division of China into East, West, Center. And what's black is coal and green is petroleum oil. If you look for renewables, it's very small. I guess you will not really see it on the primary energy production side. What's interesting to do, this is like when we do then, we aggregate again our data for East, Central, West for an indicator to come up with a national number, and then we check back what's in the national statistics. And you see this difference is like the data gaps. And then you can decide, like, if you work with national statistics only, usually you will have much lower numbers on anything. If you go to provincial statistics and use them as they are, usually you will have more on everything. And there are lots of research groups aware of this, and everybody has its methods to adjust somehow, but there's not so much transparency in the field, I would say. And maybe it's something easy to do, but it gives you a good feeling also for data challenges, what data sources you trust, and for which data also you rather consult experts, you rather see if there's some other source, something that is not official statistics, but something else, and then always have an order of magnitude in mind also that is quite big for anything you publish on China and energy. you should rather say about and give more trends than really stick to some number or a year, or when you do this, you get really careful. Publication here, yeah, this goes into modeling, and actually it's, maybe I show you the, yeah, this is something that was like, I want to spend a little time. The biggest publication I did on China, together also with many Chinese colleagues, and we were then aware of all these statistical problems, all this put out on China, and all the range of results in the scenarios, and we wanted to see when we sit together and think of like pathways for China right now, going in the future. Can we take different tools, different approaches from economic and engineering perspective, see how different they are, and then try to soft link and couple them to see, like, can we bridge some gap also, or give this, does this help us to better understand why are the modeling results so different, and how big is the gap if we take these tools we have there, and does it help to couple models to give better, better results for China? And yeah, the approach for people working on models here is mainly, to go a bit into detail, we used like a computed general equilibrium model, or my colleague in Nice in Japan, which I'm also not the expert in, but yeah, this is first part of the equation, and I use this a times model, bottom-up model, the integrated assessment model, global. Both models are global. We work together to have the same regional definitions of China. We harmonized our exogenous inputs with regards to like population assumption, global, and for the Chinese regions. This is what is needed for this population, and also GDP. And I had before in the slide, we relied on the, for global, the new shared socioeconomic pathway, which was a recent publication from another modeling group under IPCC. And then I used this to have, and from the CGE model, to have some energy service demand drivers I was feeding into TIA model, and then I get China-specific final energy demand, which can be used to adjust the CGE model in these parameters, so that the difference between the numbers calculated in every iteration can become smaller. It's very hard to to explain this shortly. Look in the paper or in the book if you need more details, or I can discuss this more. But it's, yeah, it was like 1 year of work or even more to do this. In the end, what we do then in the publication is we give like pathways, then results for in standardized units, then for from China here to global and rest of the world. And then what's really new is we zoom into China, and we can map out a bit the disparities you have between East China, Central China, and West China, first time in a global context. And it has always, the first window is the CGE model, like the top-down economic model. Here is the TIA model, and then if we combine the models with the approach I presented before, we will have this pathway. And then we did this, we made the models run and function, and we can produce so many data. We were then interested to look what are other modeler groups doing, and where do we end up with this work. And luckily, there was a big Asia modeling exercise by a US group, PNNL, done in 2012-13. They had like, more than 10 global models, a big project together over years. And they all did same scenarios for China, and they put the database public. And my Chinese colleague in Nice was part also of this team. So we had all kind of other pathways also to compare. And then it was pretty nice to see that actually if we do some soft linking, we can, or even with the models alone, or with our work and having these regional details of China new in these global models, we end up still in the pathways that are suggested by other models. for all kind of indicators, and we tested it for baseline scenario, and here is a carbon text scenario, carbon text pathway, which was a replication also what the other groups did in the Asia modeling exercise. And this is like pretty interesting work, pretty hard work, but I guess it's the way to go forward, or if one wants to really get more transparency, clarity on why China is consuming so much energy, why they import also coal right now, and things you have to approximate a bit the regional developments in China and see it in a global context and have then some discussion. This could be really expanded further, but yeah, it was towards the end of my PhD, it's being published. So almost last publication. This is one, just a quick one we did in collaboration with IRENA, International Renewable Energy Agency, to look at different future wind electricity generation outlooks. And I was contributing a bit to see also like trying to have the different tools and institutions, what are assumptions behind, can we somehow classify them, who are the ambitious organizations, who not, and where's China. And just to give, this is I guess pretty good to read. We had like all these scenarios from US Department of Energy, ExxonMobil, IEA, EASA, WWF, IRENA also, and Global Wind Energy Council and Greenpeace, which have scenarios with data available to say, okay, from like around now to 2040, 50, so much wind power generation do we expect. And here again, you see also it's really widespread. And you can see also, okay, if you need some pessimistic outlooks, go and base your work on ExxonMobil or US Department of Energy. If you want to be really, really positive, yeah, then go with Global Wind Energy Council, of course, or yeah, Greenpeace. And IEA is always a bit average in the middle, in between. And yeah, this was some side work on just wind. What's interesting in this perspective also, it has an overview also of IRENA's Renewable Energy Roadmap study to 2030. And they work together also in their scenario that is here with government counterparts and ask people like, what do you think is realistic? For your country, they collect all and then they come up with some global results. Last publication I want to introduce is the one on concentrated solar. Oh no, sorry, this is almost last. Sorry, it's another quick one. Actually on model coupling, which was a pre-step before doing this big global model scenario comparison. Here we just used the models as a test to establish some common baseline scenarios and explaining also the soft linking methodology I explained a bit before in a bit more detail for the baseline. And this is part of the publication in the Springer book. So if you want to have also a progress in the publication and work step by step, usually you will read this one first and then you go to the more complex scenario modeling, benchmarking. So I guess I already explained it. It's a different models then for different indicators, different parts of China. You can dig a bit more into the data there. And this is the last publication I want to introduce, which is over concentrated solar power plants, which is something different. We were just like having some new collaboration and had some data also, first time to look into the different CSP plants that are under construction in China. And currently there's just like one number outdated in the literature. And we had a colleague in China doing interviews, so we could establish some better national CSP database with the new projects under construction, different technology variants, tower CSP, dish CSP, parabolic trough CSP, which are there, and then set up an easy net present value or levelized cost of electricity model. So it just looks from a power plant investment perspective, how much lifetime costs you have, capital costs, technology costs, how much output you get, and then you calculate the LCOE, which is like unit of money per kilowatt hour produced over the whole life cycle, and then you can compare different technologies or use it also for country comparison. And what we've seen then that there is some preference maybe, or according to expert interviews also some aim to do a lot of local manufacturing, and then one technology stands a bit out from the others through different sensitivity analysis. Can also talk about this more in the future if somebody's interested. So if you go to the publication, you find like some good database now on these different power plants that are up there, that are new, and you see also where they are located, like more in the northern part of China. And the range also of the costs based on technology, based also which scale they were, small demonstration projects, already like a 50 megawatt utility projects, and also which local tax incentives they had. And then we do another scenario kind of sensitivity analysis if the technology gets better, if economies of scale come into play, then going forward, how much cheaper could it come? So we've been through all these different papers. I tried to wrap up in a few minutes. So it's basically my PhD was like, as the topic is very broad, very interesting, so much going on in China. And I found also so many collaborations on the way. It's like you can say it's different papers running in parallel, trying to keep China's energy sector as a big topic in mind. Not forgetting about the difficulties of statistics, where I did some initial work, trying to use this to model China with a bit more regional detail in a global context. Benchmarking and visualizing results as much as possible. And when I had some new collaborations on renewables, then we did this a bit on the side, you can say. So you have here the renewable ones. The model ones are mainly this one, and this one, and the statistic ones. And if you ask me, what about China now? According to my title, for measuring China, I can only say, I mean, it is interesting, it's challenging, it's really quickly changing. It could be already a PhD topic in itself, just to try to measure with detail what's really going on in China. And overcome some statistical hurdles, like what is invested where, and how locally different are getting the policies, and how will they cope with these regional challenges plus the global energy market. You could go much, much further into this right now. And modeling it, of course, it will not stop. It's a lot out there. But my take on it is try to be pragmatic, transparent, and try to collaborate as much as possible with Chinese researchers. There's not so much, or there can always be more collaboration, I would say, and it's really, really well possible. Try to open up a bit the black box of models more, benchmark, visualize results, and explain also the difficulties in the statistics a bit more. Then it becomes more interesting also, I guess, for the general public, policymakers. And what's really new of this work, and what I expect, I know some groups in China are also working on it, bridging a bit regional developments inside China and global developments, and then having scenarios on China, which are maybe a bit different. This is rather new and coming up more. So if you see also from my topic, like by geographic scale, I have some publications like that address like global level, then country level, of course, and if you zoom into regional level of China, you can look at these ones. And also from the time scale, I try to look a bit in the past, but not much, just with the model review. Most of it is on what's going on right now and future, long-term future towards 2050. And yeah, altogether, it's an interesting story. There are many theories, many answers. But I've seen also that it is interesting not only for me, for many, many other people as well, as I did my own scientific matrix a little bit. The first publication in Energy I had from, after 6 months, it came out in early 2014, and then you get these statistics now from the journal, like who is downloading your paper and who is paying for it. And so it was really interesting to see like where it's being read and who, even up to Turkey or Australia, people download your papers, and it's increasing, and pretty big interest also in this just general review of models. I was quite surprised, and we were approached also to write a book about it, but one could do if he's interested, but it's hard to get the data from China. And then I had also my own, as I was always going back and forth between Denmark and China, I put up my own website. Every presentation I was giving, I was putting there, every working paper, everything. So, and I always told people, so if you need more time to read it and I'm not there, just go on the website, send me a mail later or look at it. And I really seen also how much traffic on the website there was there when I was in China and just going to some student group, and people were really interested in reading it. And another funny thing happened also, that was my working paper on statistics was then also sent to Chinese social media from somebody I didn't even know. But I could meet later in the PhD, and it had some discussion then by Chinese experts in the China media, like about statistics you see there. So I would say also there's, a lot of further avenues of research when somebody has time or wants to continue this. I didn't go very far on really specific policies because of time, but now there's so many national policies coming up for the next carbon COP conference of the parties in Paris. You could look at this. One could also include more analysis in the nexus of energy, water, air quality, which is a big, big topic in China. One could do more on technology-specific research in the different regions of China than also with other models, not only this one, of course. And what could be interesting is also have more collaboration and country comparison between China and countries with similar coal-based energy systems like India, South Africa, because they right now have the same challenges also and same fast growth, and lots of countries also looking to China, what they are doing. So could be interesting. And so far so good. Thanks for your attention. I hope it was not too confusing. It's a really short overview of 3 years of work, and I hope you have some interest maybe in some bits and pieces, and you can find them later hopefully easily in the PhD thesis or ask me. And some Chinese philosophy as well. It was a start. Thank you.
Thank you very much. Thank you. So now we will have a short break. And for those of you that are coffee drinkers, there's a coffee machine downstairs. We are actually packing at the time being. The department here is moving to Lyngby. So all our China is packed down. So you have to go downstairs and to the automat to get a cup of coffee. And then we start again 5 minutes to 2. And for those of you that want to have questions for Peggy, besides the examiners and the supervisor, then please hand me a note if you have any questions here at the break. We start again 5 to 2.